In episodes 6 and 7 of the atmospherics tutorials, I talked about airlocks, standard airlocks with a console. How to build them, why to build them, how to make them faster. So here in the programming series, in the previous episode, which was number 7, I took it a bit far and thought let's make a custom airlock, which is alright, but this thing is way too complex. Quite not for beginners. So what I want to do today, the same thing again, with a very simple airlock. I want to do that in this building, so this old airlock needs to go first. Uh-oh! That was not the plan. Guess we first have to evacuate all the oxygen here. Oh, that's not much better. Let's go back inside. Oh, the airlock is already broken.
Waste tank critical.
Yeah, with a lot of patience. So we can break this open now, yes? Nice. There, now we can start fresh. This airlock will be much simpler because we're not gonna have just one vent in there, but two. We are also not gonna be bothering with repressurization. We just do explosive decompression. Door opens, we're on the other side. End of story. We are also not gonna be bothering with the door buttons. We will just use an occupancy sensor. This will make the logic much less complicated. First we define the devices, the gas sensor type and name, the occupancy sensor type and name, the glass doors type and name, and the powered vents type and name. We're definitely going to have a main loop. And we're definitely going to set the doors to logic mode because we don't want the buttons to do anything. Just the occupancy sensor should do it all. First, the basic cables. The logic chip. Power to the vents, else they're not large powered vents. Occupancy sensor and gas sensor. And finally we name everything. Okay. This one's the outer vent because, I mean, the choice is relatively arbitrary, but it seems rather opportune to put the pipe right here. Concordantly, this is the inner one. So everything has been set up. We have the cables, we have the vents, we have the chip, we have the sensors, everything has been named. It's time to program. Again, I'm not using the laptop, but the hardwired computer, so for convenience I connected it directly to the AIRLOCK circuit, which is normally not advisable, but it's not going to be on when I don't program. Because the laptop requires me to put the chip in the laptop back and forth the whole time. That's not convenient for testing things. Okay, so I can close this now. Once again, let's first check if you have control over the devices. We do. Oops. Haha. And finally the sensors. Gas sensor temperature. And occupancy sensor. Which brings us to the next topic, how to trigger the airlock. See, when we're standing in here, the occupancy sensor says, someone is in here, which means that the airlock would think, oh, I better cycle then. But I'm still here. Yeah, that's why I keep cycling. That's not good. So how do we determine then whether the airlock should be cycled? Oh, wait. This is what we want to do. Check if entered airlock. The trick is relatively simple. We just check if something is currently, someone is currently in the airlock, and we remember this value from the previous cycle of the main loop. And so we compare against the previous value. If there's a difference, then someone entered or exited. And if it is currently occupied, then the combination of these two facts means, yeah, someone entered. And that's what we want to know. So we create this new value in R1, which so far isn't used yet, not equal. If R0 and occupied previous, so occupied current and occupied previous, are not equal, then this will be 1. I'm not writing this directly into cycle airlock please, because maybe cycle airlock please is already 1. And we don't want to reset that to 0 or something. We just want to like write a letter that is written then and exists. And we might want to add to the letter, but we wouldn't overwrite or tear apart the existing letter. That's why we just combine these two bits. We're saying cycle airlock please will now be set to the combination of cycle airlock please and whether there's a difference between currently occupied and previously occupied. And of course we have to remember if the airlock is currently occupied. Maybe it's even best placed here. So we're loading, is something occupying the airlock? We are comparing that with the previous occupation information into R1, temporary register. And before we do something with this inside, we copy. Oh, that's wrong. We copy into occupied previous the value of R0, which is the current knowledge of occupation. And then we combine these two information in cycle airlock please. So if this was already 1, it will stay 1. If it, even if currently no one is in the airlock. In the previous video, I used some kind of state machine. I had a register that said this is the current airlock state. But can't we just go by the doors? I mean, we could say, airlock, start running, and the airlock wakes up and thinks, oh, both my doors are open. I will now make the following assumption. Close the doors, evacuate towards the outside, because both doors had been open. That is something that never happens in normal airlock situations. But if only this door is closed and this door is open, then the airlock knows what's up and can just derive its situation from the state of the doors. So we can say, hey, airlock, make a decision based upon the state of the doors. And since the doors take some time to open and close, we will just say, hey, make a decision based upon the state of the doors, but at the beginning of this decision-making process, first wait for both doors to be idle, and then you log what the door state is and you make your decision. Okay, that's already the door state check. Start, yield, check if someone's in the airlock and someone entered the airlock. This doesn't have a yield statement, it doesn't need one because we're not setting any values, we're just checking what's going on. So we can just have this the yield up here like we normally have. And then I'm saying find out if this door is idle. If idle is a 0, as in it is not idle, as in it is busy, equal to 0, then jump back to start. And we do this for both doors. Now that we have waited for both doors to have reached whatever state they are currently in the process of reaching, now we load into R0 and R1 whether the outer and inner doors are open, and we add both together in the next register, or in any other register. And then we're saying if this is equal to 0, then both doors are closed. I mean, if this one is open, no, 0. And this one is open, no, 0. That is 0 plus 0 is still 0, equal to 0, so both doors are closed. Now, if instead Oh, little mistake here. I wanted to neatly wrap it up like the last one shall be both doors are open, oh, as the fallback, but that doesn't fly. If I'm checking here, if this door is open, I cannot assume that the other door is not open meanwhile, so Okay, then let's do it like this. So, if both open states added together are the value 2, then this means that both doors are open. The alarm state, basically. If that is 0, then both doors are closed. If the first one, outer door, is not equal to 0, then the outer door is open, and the only possible state that remains is that the inner door is open. I could, of course, just check this, like here, to keep it consistent. Like I also just changed this from here to this, just for consistency. But I don't know. It's the only logical remaining state, and I don't want to leave any holes. I don't know, maybe it's just arbitrary, but it feels safer like this. I know here this is the end. When I read the source code later, I know this is the end. I don't have to think through all the states here and think that, oh, there's an equal here, this will continue executing, and no, it won't. It can't execute past this. So if both doors are open, what we want to do definitely is we want to close them. What we also want is to use the vent that pumps to the outer side to be on. Oh wait, we also have to set the mode, right? But not in this place. But here, before the main loop, where we initialize the doors to be in logic mode. Because anything and everything that these vents will ever be doing is suck from the airlock box, either towards the outside or towards inside the station. And they will be on and off, but they will not change mode, so we save a few lines. So if the airlock detects both doors are open, it will close both of them, will evacuate the airlock towards the outside, and then we have to wait for the vacuum. This is something we will have to do in other places too, so we can just make a nice subroutine, or rather just some code block, because from there, once it's done, we will just jump back to start. Now here I'm waiting for the vacuum. Load from the gas sensor the pressure into R0. If it is equal to 0, then go back to start. Otherwise, yield one time and jump back here and then see if the pressure is now 0. Except I'm doing it slightly differently. I'm not jumping back to start, I'm jumping back to something I just placed here, start post yield. I'm already thinking about removing the yield statement entirely up here, but I'm not sure yet where I would then have to place some yield and where not. So I will just do the opposite. I will just assume there should be a yield here, and whenever I think, no, now I don't want to yield, I will call this, because then I'm not going to yield. Here, what happens, let's say we're evacuating, it's not equal to 0, the pressure is not equal to 0, so we yield, we jump back to vacuum. Here, wait for vacuum, and then we check again if it is empty. Now we realize that it is empty. What should it do now? It should take action instead of waiting another time. There's no good reason for it to wait now, so we'll just not do this. This should accelerate the airlock cycle a bit. But now for a very interesting part. Both doors are closed. That's indeed even the case after this here, where we say both doors are open, we close both of them, evacuate, we wait for vacuum, and from here if we just go back to start, where we check if someone entered the airlock, and then we wait for the doors to be idle if they are not idle. If they are idle, then we just continue. This will not have any delay. And then we check for the doors. So in other words, we are seeing both doors are open, we're closing them, evacuate, and then we arrive here at both doors are closed. What is supposed to be the next step? And this is also the situation that we arrive at when we are legitimately entering the airlock and pushing the button, cycling from outside to inside or inside to outside. The airlock needs to know what to do in this situation because it is undefined. So we need another thing up here. This will then be equivalent to the state variable that we had in the much more complicated code, except it just needs to have two values, inside and outside. Here, coming from the outside. So if this is 1, then when the airlock has both doors closed and it sees this, then it should open the inside. Or will I rename this? Yeah, going inside may be better. We don't have to worry that this might not be initialized with the correct value when we first start up the airlock, because the moment we start checking this, it should already be set to a meaningful value. Actually, no, what am I saying? Let's say both doors are closed for whatever reason when we start up the chip for the first time. What will happen then? it will see here that both doors are closed, and then whatever it will do down here will base its decision upon this value here. And this would be 0 at the very first start of the chip. And so we would be going not inside, but outside, which means that it would open the door towards the outside. While we are working inside the airlock for the first time, I don't think it should do that, so I will flip this. Yep, going outside. So both doors are open at first start, maybe. Close them, evacuate, and already prepare that going outside is 0, because we want the inside door to open once we are coming back from the vacuum. Okay, both doors are closed. If going outside, which is 1 if we are actually in the process of going outside, that's why we write going outside 0 here, when both doors are open, and we just close them, emergency, evacuate to the outside, and then we want to go inside, open the door inside. That's why we are writing 0 here. If it is if it is equal to 0, if going outside is equal to 0, so we are going inside, then we want the door to the inside to open. 1, 2, 3. We branch relative 1, 2, 3. So we end up here, and afterwards we jump back to start, which will have a yield. And that's okay, because the door will take some time to open. More than 1 yield, I'm pretty sure. Anyway, but if going outside is not equal to 0, if going outside is 1, then we will just continue here, and so we will open the door to the outside. So if the outer door is open, then we check if cycle airlock please is 1. Or rather, if it's not 1, if it's equal to 0, we just jump back to start. But if the message cycle airlock please was written into this register, then we close the outer door, which will take a while, but we bluntly start to evacuate the airlock right away. This should make the airlock really fast. And then we jump to wait for vacuum. Okay, I forgot one thing. This. We are going inside. We are on the outside, the outer door is open, and someone entered the airlock, so we have this trigger here, we continue here. And so we close the outer door, we start the evacuation of the airlock. We are writing already that wait for vacuum, that if both doors are closed, which they are soon, we want to go to the inside, so going outside is 0, and then we say jump, wait for vacuum. And finally, inner door is open. I mean, this might already be the entire airlock code, man. This little bit here, and super fast too, but I don't know yet if it works. So, this is just a copy of that, but inverted. We're checking is cycle airlock please triggered, equal to 0, no, okay, then jump back to start. Otherwise, since we are on the inside, the inner door is open, we close the inner door. We start cycling from the airlock's we start moving the airlock's content towards the inside with the inner vent, and we are saying that we're in the process of going outside and we are waiting for vacuum. I have no clue if this works. Let's see. Okay, it's a bit different from what I expected. I guess that this messaging system with the occupancy sensor doesn't quite work yet. But if this thing is properly separating the atmospheres, then it's pretty fast, man. Now I have to investigate what's wrong. Oh, of course. Maybe you can think of it. What is the mistake? I'm checking if cycle airlock please has been triggered. Now I'm entering the airlock, so it is triggered, so we can move on here and do stuff. The problem is this stays triggered. Thank you, we have received the message, you can clear it now. That should have been the mistake. Okay, slight problem. Oh, they're both pumping now? There is some logic error here. Oh, I forgot to turn off the vents. And also, what do I do now that I'm here? So, 2 mistakes. 1, we have to turn off the vents. This is wait for vacuum. We're checking if the pressure is equal to 0, but I'm not jumping to start post yield right away. I'm jumping relative by 3 lines. 1, 2, 3. But if it is not yet 0, then we yield and jump back to wait for vacuum. So then we turn off both vents. We don't care which one is currently on. This is just a universal function for this situation, and it's not wrong to turn both of them off. This will probably now not kick, because there's just nothing that calls wait for vacuum. because of the stupid programming error. Don't mind if I do. Okay, that's better. It doesn't keep cycling. Oh. Yeah, right. A little bit that I forgot. Oh, what will I do now? No, I want to get inside. Good thing we don't have any valuable atmosphere in here yet, huh? Down here, where we're saying check if entered airlock, we just have to check if something is currently in the airlock. That's the part that I forgot. I explained in the beginning, I didn't implement it. So let's check again. Occupancy sensor, is it activated? This is then 1. So I'm saying if not equal, whether something's in there right now versus if something was in there before, then this will be 1. And then I'm immediately saying I'm remembering the current occupancy information for next time, so the previous value exists in the first place. And here now I'm saying is the occupancy currently 0. Is it equal to 0? Then just jump back to wherever this was called from. Otherwise, just or whether there's a difference into the cycle airlock, please, and yeah. Better? I'm leaving the airlock and... Did I forget to export? Yeah, I just bluntly forgot to export, so continue occupied, occupied, not occupied. Okay, basically the airlock works. There's just this ugly problem, what if I'm on the outside when it's cycled? Then I can't get in. For that we can use the motion sensor, which some people wonder why it exists. Well, the occupancy sensor, and we could have used the motion sensor in here also, would have had the same effect, checks for the current box if it's occupied. And the occupancy sensor checks whether something's in the room, somewhere here in this tower. But I want to find out if someone's waiting here. And there it is, the motion sensor. Not yet programmed, cabled to the airlock logic. Oh, how convenient is it to just walk from the inside to the outside on Vulcan at that speed, man. That's the way. So let's add this new device into the mix. A mix which still has quite a lot of space. Like so. Of course we need to name them too. Oh, how fast this is. Oink. Now it gets a bit tricky because we can't just say, well, target the airlock if something is there. Because what if the airlock is already on the right side? So we add another call up here. Check if approaching closed airlock. Does this do the trick? I'm loading whether the outer door is open. If that is not equal to 0, as in the outer door is open, then I jump relative 3 lines, 1, 2, 3. If the outer door is closed though, then I do care whether someone's waiting on the outside. So I'm loading from the outside motion sensor, the value activated into R0, and whatever that value may be, 0 or 1, I don't care, I will just OR that into this little letter that we are writing to the rest of the system. Hey, circle the airlock, please. And this is the same thing for the inside. Load badge named R0 close class door, ins door in, open. If it is not equal to 0, then 1, 2, 3. I could also jump to RA right away, but it's better to keep it symmetrical for readability. And if this door though is equal to 0, then it's closed. Then I care if someone's waiting on the inside trying to get out. Let's see if this works. Well, first export. This will toggle the airlock once more, because I still have this little command in there that does that. It's cycling. And it keeps cycling. And that's not the way God intended. I think I have an idea why this is. The moment when this checks what's going on here, if I'm standing here waiting here, the door might still be in motion, and then we are writing this letter basically, which becomes invalid, but will just stay there, so the airlock keeps toggling. I guess that's the problem. If that is the problem, then the bug should be fixable just by placing this here, where we have waited successfully for the doors to be idle. Let's see. Sadly, no, that's not the reason. Yeah, I guess I have a clearer idea now of what's going on. I haven't changed anything, so let's see. Burp. And burp. So it is a timing issue. The check is alright, but the way the overall program flow works in regards to these things, that's not yet alright. Yeah, I think the bug is pretty clear, because okay, look at this. I'm standing on the inside, the outer door is open, the inner door is therefore closed, if this is called. So then we cycle towards the inside, and then, both doors are closed now, and we're waiting for the vacuum, which is here. It waits, and when it's done, it turns off the vents, and it jumps back to start post-yield. So in this situation, both doors are closed, meaning that the trigger value down here, the trigger situation, is still the same. I'm still standing on the inside, the door is closed, and so it thinks, let's add this trigger here to the airlock. And so it will cycle again. That's the mistake. I have to check both doors. Or rather, this could be the answer. I'm flipping this. I'm not checking if the outer door is... Okay, this is the outer motion sensor, and I skipped the outer motion sensor check when the outer door was open. So, but if both doors are closed, which is not the situation where the motion sensor should kick, then it would also do this thing. But what if I just check the opposite door? If the outer door is... okay, I'm checking the outer sensor, but only if the inner door is open. I'm loading the inner door state. If the inner door is open, then it will not be equal to 0, so we will end up here. So the inner doors are open, then I'm checking if the outer motion sensor is triggered. But if both doors are closed, or if the outer door is open, then this will not kick. This is probably the fix, man. Let's see. This cycles, yeah, I still have this move in there at the top of the main loop. It cycles. Looking good. I think we have it, man. So... Can I get inside, please? Apparently. This works like a charm, man. So it's time to close everything up and swap out the atmosphere, and to check if it's really airtight. Meanwhile, I'm preparing to close this up so we get more precise measurements as to the, well, purity of this airlock. Smaller room, you know? Okay, evacuated.